Hello everyone, welcome back to the channel. Now in this video we are going to calculate what is the minimum value in the tree. Now in the last video we have implemented this height method, right? So and actually this implementation we are doing for binary tree, considering we have to find the height of a binary tree or minimum of a binary tree. The implementation is much easier if you are doing the same thing in binary search tree. So whatever is the leaf node which is there in the most left, right, that is the minimum value in the binary search tree. Okay, so it becomes easier with binary search tree, to be honest. Now still this implementation I'm going to show you for binary tree. It will work for both, to be honest. So let's do that. Option enter, create. Now this will return a integer. Now we need a root node to iterate. We have created that method, and in this method we need two things. First, our recursive call, and second, the base condition. So the base condition is really simple. If okay, we have already have that condition. Okay, here if it's a leaf node, then here we are returning 1 because we are calculating the height of the tree, and there we have to return the minimum value. So we'll be returning whatever the root value is there. I think I can extract this in a method is leaf. Okay, perfect. Even this does not need an argument. Okay, we can make use of root directly from the class level. Okay, it's not able to use it, huh? Okay, so I have extracted that particular condition in a method that is leaf. What this method is doing, it is checking if this particular node is leaf node or not. If it is a leaf node, then it is returning 1 for the height, and same this method we can use to calculate the minimum in a binary tree. How do we do that? If it's a leaf node, in that case we want to return the root node value. Okay, else how we are going to return the minimum? So first, whatever is the left node and right node is there, right, we are going to have comparison between these two, and once we are able to find the minimum value between left node and right node, and then with that particular minimum value we are going to have a comparison with root node. Okay, so first comparison between left and right node, and then second comparison is between that particular minimum value and with the root node. So in the end we will have the minimum value. Let's write that in one line itself, math dot minimum. So final comparison will be root value, right? But root value will be compared with what? Whatever is the minimum value for between left child, that is root dot left child, and minimum of root dot right child. Yes, and that's it. Recursively it will calculate what is the minimum value between this left and right child, right? Whatever value it is able to get, and that value will be compared with the root node value, and then it will keep on returning it back, and you will get your answer of the minimum node. So let's run this method and see if we are able to get 1. I guess in this one we are supposed to get. Okay, cannot find the value because the root is null. Okay, why the root is null? Okay, I guess we need to change the way we have implemented our leaf is leaf method. Let's pass the root node here so that it is able to do the comparison between these two, and let's pass that root node here as well. Yes, we are passing. Let's pass it here as well. Okay, now we are supposed to get the right answer. Let's run it again. We are supposed to get 1. Yes, and we are getting 1. So core Java knowledge is actually really important if you want to understand the pointers, references, and all those things. Okay, so we are done with our minimum method implementation. What we have done, we have called the minimum method, which has taken the root node internally, and it is checking whenever it is a leaf node, it is returning the value, and then same thing we are doing with the left child and the right child. And once we know what is the minimum between these two, we are doing the comparison between root value and the minimum of these two, and that's how we are able to get the minimum value of the tree. So yes, so that's all I wanted to explain as part of this video. See you in the next one. May the source be with you.